Hello everyone, and welcome to this next video of the series Math Olympiad Training Problems of 2025. The problem we have selected today has a statement as follows. Three real numbers m and p, which are greater or equal to 0, are such that m is greater than n is greater than p, and that m minus n plus p divided for m plus n plus p is equal to m minus n minus p divided for m plus n minus p. Prove that p is equal to 0. If you have any idea how to solve this problem, please pause the video and share in the comments if you want your solution. If not, we can go through one solution in this case that I am going to share with you right now. So here the calculations are a little bit heavy, so please bear with me. So we are given these three real positive numbers, m and p greater or equal to 0, such that m is greater than n is greater than p, and that m minus n plus p divided for m plus n plus p is equal to m minus n minus p divided for m plus n minus p. We are asked to prove that in this equation over here and with these conditions, p is equal to 0. Now, given that we have these numbers m is greater than n is greater than p, and m and p are part of positive real numbers, we can say that, of course, m plus n plus p is different from 0, and m plus n minus p is different than 0 because m plus n, of course, will be greater than p. So the difference, of course, will be different from 0. Now, we can multiply both sides of this given equation over here with n plus p times m plus n minus p. We can do this because all these factors are both positive factors, and we can do this operation. Now, by multiplying this equation over here on both sides with this expression, we will get that m minus n plus p times m plus n minus p on the left hand side is equal to m plus n plus p times m minus n minus p on the right hand side. Now we do a little bit of regrouping, and the left hand side will be transformed in m minus n minus p times m plus n minus p is equal to m plus n minus p times m minus n plus p. We call this the form of the equation number 1. Now, this equation over here can be furtherly transformed because we see that we can transform this equation over here in difference of powers. So this equation will be the left hand side m squared minus n minus p all squared, while the right hand side will be m squared minus n plus p all squared. And this is the equation number 2. Now, of course, in this equation number 2, we can simplify m squared on both sides, and by multiplying with minus 1, we will get the other form of this equation, which is n minus p all squared is equal to n plus p all squared. We do the operations on both sides of this equation, and we will get that n squared minus 2np plus p squared is equal to n squared plus 2np plus p squared. We simplify n squared and p squared on both sides, and we will get that 4np is equal to 0. This is the third and final form of this equation. Now, in this equation over here, the solutions are such that n is equal to 0, which is not acceptable, because if n would be equal to 0, then p, which is smaller to n, will also be equal to 0, and this condition would not be fulfilled. So n equal to 0 is not acceptable. Then another possible solution is p equal to 0, which is what we are asked to prove. And this is an acceptable solution. And the final possible solution is that n equal to p is equal to 0, which again is not acceptable because it breaches the conditions of the problem. So the only possible and acceptable solution of this equation over here, which derived from the initial equation, is p equal to 0, which is what we initially wanted to prove in this problem. So if you guys liked this solution, please make sure to support our channel. Thank you for your time and hope to see you on our next videos. Up to then, have a nice day.